Hey guys, Nick from Aguazio, here to show you the tutorial for train, compare, and register models. We're going to run through it together and see what it looks like in Jupyter as well as the UI. If you'd like to follow along at home, go to the top of the page and click Download as a Jupyter Notebook. You can find this page on the left-hand side under Tutorials and Examples. I'd like to call out this page in the docs called Tutorials and Examples. It has just about everything you need to get started with MLRun, including the quick start, so I'd start there, as well as targeted tutorials on specific areas like training and serving and a lot more. We're going to be doing train, compare, and register models today, but I strongly recommend you check out the others as well. So I've opened up the notebook here in Jupyter and we'll go ahead and run through it. I want to note that I will not be covering everything in the notebook, so I encourage you to read through the whole thing to get all the details, but I will be covering all the important parts. So the first thing we'll be doing is getting our project using MLRun.getOrCreateProject. This will create one if it doesn't exist and grab it if it does, passing in the name and some other parameters, and that gives us our MLRun project object, which we'll be using to add functions to and execute those functions later on. Next, we'll be creating our MLRun function to train the model using this piece of code. It's a pretty standard training script, mainly sklearn and pandas, that is splitting a data set, creating a gradient boosted classifier, and then fitting the model using our dataset splits. The only thing we're adding from MLRun is the MLRun handler decorator, which we saw in the quick start. This tells us what we want to run with MLRun. And then this apply MLRun piece of code, where you pass in your model and your test sets, which does a lot behind the scenes. This actually logs the model. It creates evaluation metrics like accuracy and F1 score. It creates plots and charts like confusion matrices, and does a lot more. So we'll see that when we actually run the code, but this is pretty much the only piece that we need to apply MLOps to our existing training code. I'd like to call out that this apply MLRun piece of code is framework specific. In this case, it's for sklearn, but we also have support for other common frameworks like TensorFlow Keras, PyTorch, sklearn, XGBoost, and LightGBM, and there's a lot more on the way. Next, we'll create the MLRun function using the code we just saw with project.setFunction, pass in the path to our code as well as the name and some parameters like the fact we want to run it as a job with this Docker image and this Python function. Then you can go ahead and save your project to add the function to your project. Next, we can run the function, first by quickly creating a CSV file for our dataset, just using some sklearn data, and then passing in that data to project.run function with the name of our function, some parameters including the dataset that we just created, as well as local equals true, which means it will run in our Jupyter environment instead of on Kubernetes. From there, once you run it, you'll see this nice printout with a bunch of different information, and you can also open up this link here to see in the UI, which will show you things like parameters, results, as well as any artifacts that were part of the run, such as the model itself, confusion matrix, test set, and a lot more. There's also a really nice capability to export the model and all of its relevant metadata to a zip file. This includes the model itself, plots, charts, metrics, so on and so forth. This is really nice if you have separate staging, dev, and prod environments, where you can take your model, import and export in those different environments, and take everything with you. Next, we'll be doing some hyperparameter tuning using a grid search and looking for the maximum accuracy. Because we're running our hyperparameter tuning on Kubernetes, we need a way to access our dataset, and the way we'll do that is first by logging it. Before, since we were running in Jupyter, we can just access the local CSV file, but now that we're running in containers, we need to access it somehow. That's why we're logging the dataset first. Logging a dataset in this way is really powerful because it abstracts the storage and retrieval of your data. You can log something locally, or you can also log something in a remote location like S3. Regardless, all you need to worry about is your dataset artifact, and MLRun will handle the implementation under the hood. Then we'll go ahead and use project.run function, again passing in our trainer function that we created earlier, the path to our dataset, and then a new parameter we haven't seen before called hyperparams. This is our grid of hyperparameters, as well as the selector, which tells MLRun how to select the best run. This is in the format of condition.metric, for example, max.accuracy or min.error. And I want to note that this metric can be anything you'd like. It could be max.myCustomMetric, for example. Once you run it, it is executing on Kubernetes because we haven't specified local. Local equals false is the default. We'll see job is running in the background with the name of a Kubernetes pod, as well as the best iteration is 3 using this criteria. So it went ahead, it went through all those iterations in the grid search and found the best one. And then we have a printout here with information on that run. We can also click here to open it in the experiment tracking UI. and see all the things that we would normally see, but also under the Results tab, we can see a list of all the individual permutations of those hyperparameters, as well as this nice little badge icon which shows you which one was the best. After running, you can compare all the different runs in a table as well as a parallel coordinates plot. It's nice and interactive, so you can see which different hyperparameters led to different results, and then switch between different metrics that you logged, for example, F1 versus accuracy, so on and so forth. There is also a table view. The formatting's a little weird because I'm zoomed in, but if you zoom out, it is a nice table that you can compare the metrics versus parameters for all your individual runs. Now that we've trained our model, we can serve it using an MLRun serving function. We can create one using MLRun.new function, pass in some parameters, and the kind is equal to serving. And then we can add our model with serving function.addModel, specify the model path as the output from our hyperparameter tuning run, and the class name, which is the behavior of the model, is the default sklearn model server. Finally, we can create our mock server using serving function.toMockServer, and then pass in some test data, and we get an output exactly like we'd expect from our model server. So that's it for the Train, Compare, and Register Models tutorial. Thank you so much for watching till the end. If you found this helpful, I strongly recommend checking out the rest of the tutorials that focus on different areas of the framework like serving and monitoring. Each one has its own dedicated tutorial as well as a video. Thank you so much. We'll see you in the next one.